If you remember, 78 increased by 15%. You could do this one of two ways. You could do 15% of 78, which if you use your calculator, you get 11.7, and then you could add that to the 78. Or if you just multiply 78 times 1.15, that automatically adds in the 15%, and you get 89.7. So this is the quicker route. It means the exact same thing as that plus 78. The 78 is the 1 keeping the 78, and the 15% is right here. And I could even put a plus in the middle if that makes more sense. All right, so then 34 decreased by 32%. If we go with this, if you're decreasing by 32%, the whole is 1, and 1 minus 0.32 is 0.68. So if you multiply 34 times 0.68, you'll just get the answer right away, which is 23.12. You could multiply it by 32 and then subtract it, but that would be the easier way, just multiplying it by 0.68. That's what you're keeping. Okay, when you're solving things with parentheses, the first and foremost step is to get rid of the parentheses. We're going to undo the order of operations, but we cannot have the parentheses in here. So we have 8x minus 20. Now I'm going to slash and dash this just so I do not lose that negative. So negative 2x and then a positive 8. And then we have 2x plus 6x minus 12. So that's the first step. No parentheses. The second step is to simplify each side of the equation. So over here, I'm going to put my x's together, and they're on the same side of the equation, so I'm just doing what it says. 8x minus 2x is 6x. And then my numbers, negative 20 plus 8 is negative 12. And then on this other side, we've got the 2x and the 6x. That's the same, which is 8x minus 12. Now, you might know what it is just looking at it, but if you're going to keep on cruising here, you're going to put letters on the left and all of the numbers on the right. So using that methodology here, we're going to subtract 8x, getting a negative 2x. And then we would add 12 to both sides, getting negative 2x equals 0. So when you solve for x through dividing, you get x is 0. It's a really good tactic to take that and plug it back in and just make sure it works. So if we do that really quickly, 4 times negative 5 is negative 20, minus 2 times 0 minus 4 is negative 4, so that'd be a negative 8. That'd be plus 8. So we've got 12. This whole side equals 12. And then does this whole side equal 12? 2 times 0 is 0, and 0 minus 2 is 6 times negative 2, and that's a negative 12. So that is also a negative because of the negative 20, and it works. All right. So we're now going to talk about the x-intercept and y-intercept. On a graph, the x-intercept is where it crosses the x-axis right here. If you wrote this as an ordered pair, we would go over 5 up 0. So the x-intercept is when y equals 0. Basically, if you have an equation, you can plug 0 in for y and solve for x. So the y-intercept is the exact opposite. The y-intercept, if we were to write this point right here, 1, 2, 3, 4, 5.5, over 0. Just kidding. 0, 5.5. See how we're over 0, up 5.5? This is your x value. So the y-intercept can be found when x is equal to 0, and then you solve for y. So if we're going to graph this equation using the x and y-intercept, you can plug 0 in for x and solve for y. When we plug 0 in for x and solve for y, we get 0 in for x. So I'm going to not even look at this, because 0 times 2 is 0. So we would get negative 4y equals 8, because I just plugged 0 in for x, which means y equals negative 2. So that point is 0, negative 2. That's our y-intercept. And then you do the exact same thing, finding your x-intercept. I'll write y-intercept. So we're going to plug 0 in for y now. 0 times anything is 0. So y would equal 0 for the x-intercept. That means this doesn't exist. So we're left with 2x equaling 8. If you divide by 2, you get x equals 4. So this time our ordered pair is 4, 0. Now, we know this is linear because it's written in this form. This form is called ax plus by equals c, and that's called standard form. So if something's written in standard form, and we know it's linear, we only need 2 points to graph it, because linear lines, you only need 2 points, because you know they're linear. So we can actually draw our line right here. Now, does it make sense that this is a positive slope? I always like to look at things in y equals mx plus b. So if we subtract 2x from both sides so that we isolate the y, we have negative 4y equals negative 2x plus 8. And then to get the y completely alone, we would divide by negative 4. So we would get, I'm going to actually move these boxes, which is showing what I just did. Y equaling 1/2 x plus negative 2. Now this is the b, negative 2. And then this is your rise over your run. So we're going over 2, up 1, over 2, up 1, over 2, up 1, over 2, up 1. So this is your perfect line, over 2, up 1, with that slope that's a half and an intercept of 2. All right, if you have an equation like this, those fractions are unnecessarily problematic. So if you think about your least common multiple, that means what could we multiply this by to get rid of both the 5 and the 3? And 5 times 3 is 15. So if we multiply this whole thing by 15, 15 times 3 divided by 5 would be 3 times 3, which is 9, because the 5s will cancel. And then 15 times 2 is 30. And then 15 times 2 divided by 3 is going to be 10. Do you see how that is way nicer of an equation to work with? And then if we rewrite it so the y is on the left, it'll even be that much better, because it's even closer to y equals mx plus b. And if we wanted a true y equals mx plus b, we could divide by 10. And 30 over 10 is 3. And if we wanted it in standard form, this is y-intercept form, we could just bring this 9x back. So like negative 9x plus 10y equals negative 30. So this equation is the same as this equation, which is the same as the initial equation, which is not looking very enjoyable to work with. So if you look at the second one down here, we've got a 2, a 5, and a 3 all in the denominator. So if we multiply by 15, we're going to get a decimal with the 2. So if you think about 5 times 2 times 3, that's 30. So if we multiply this whole thing by 30, we're going to get 15x plus, so I'm thinking 30 divided by 5 is 6, and 6 times 2 is 12. And then I'm thinking 30 divided by 3 is 10, and 10 times 2 is 20. And that's standard form. I'm just going to leave it at that. It's not asking us to find other forms. But that's going to be way easier to analyze without the fractions. So the first step is also to get rid of fractions. All right, Micah collects nickels and dimes. He has $3.90 in nickels and dimes. So I'm going to right away write equals $3.90. So N is the number of nickels, D is the number of dimes. So nickels are representing 5 cents, so 5 cents per nickel plus 10 cents per dime. Now again, we've got this whole decimal thing. So let's go ahead and get rid of the decimals by multiplying by 100, kind of like a fraction. So if we do that, we're going to get 5n plus 10d equals 390. So if we graph our equation, the easiest way to graph something that we know is linear is to get the x-intercept and the y-intercept. So as you can see, nickels is like our x, and the dimes is like our y. Whoops, that's supposed to say y, because this is our x-axis, and this is our y-axis, and these are our titles. In this case, there's not like an independent and a dependent, so we're just going to go with this. So then I'm going to put $3.90 coin collection. That would be a good title. All right, so if I plug 0 in for x, I'm finding the y-intercept. So if I do that, I'm going to plug 0 in for x. So 10d equals 390. And if you divide by 10, that means d is 39. So our point is 0, 39. So I'm probably not going to count by ones, because that's 10 right there. So maybe count by twos. If we count by twos, that'd be 20. And this would be 30. And this would be 40. So 0, 39 is right here. And then let's find our x-intercept, and that means to plug 0 in for y. So y right here would be 0. That would yield 5n equaling 390. And then you could use a calculator, 390 divided by 5, which gives you 78, or you can divide it out the long way. So this ordered pair point is 78, 0. This again is our x-intercept. So that means we have to go over to 78 on this axis. Probably count by 5s. 30, 40, 50, 60, 70, 80. So 78 is going to be right about there. So our line of all the possibilities is the straight line from the 2. Whoa, let's pretend that's straight. See, I can't put a ruler on here because, oh my. Okay, I'm going third time's a charm, right? Okay, let me erase these messed up things. So your perfectly straight line with a straight edge, if you can do that, but I can't do that on the board because it just messes it up. Now I can't erase. But all right, you've got your beautiful straight line from this point all the way down to that point. So how many dimes does Micah have if he has 24 nickels? So we can plug 24 in for nickels. And solve. So 5 times 24 is 120. So if you subtract 120 from both sides, you get 10D equaling 270. And if you divide by 10, D is 27. So that's the ordered pair, 24, 27. And that should be right on our line. So 24 is right here. So if I trace that up to my amazingly straight line, 2, 4, this is 26, 27s, right here. It should hit right on, which that's beautifully a miracle.